we have go through if, else, and else if. And all these conditions are Boolean expressions. All the if, else control logic is based on Boolean expressions result. Now, Boolean expression can be single entry. Is it cold today, for example? Or is it raining outside? Or if this integer is greater than 0. But sometimes you may want to combine different Boolean expressions together to get a calculation result of the Boolean expression of the final condition. Is that cold and raining? That's an example. Is this number greater than 100 and less than or less than 0? Greater than 100 or less than 0 basically means it's not a valid score, right? So these are the things that we will calculate, what we call logical operation. You are calculating a result based on different Boolean expressions and a logical operator. Java provides two binary logical operators, ampersand, ampersand, and pipe, pipe, that are used to combine Boolean expressions to form a new Boolean result. Java also provides one unary logical operator, exclamation mark, to reverse the truth of a Boolean expression. So first of all, let's see all these three operators. The AND operator connects two Boolean expressions into one. Both expressions must be true for the overall expression to be true. Is that the raining and the cold? If it's raining and hot, then it's not true. If it's not raining but cold, it is still not true. Only when it's raining and cold, then it's true. The OR operator connects two Boolean expressions into one. One or both expression must be true for the overall expression to be true. Is that the greater than one, is the score greater than 100 or less than 0? If I have a number 101, it's greater than 0, greater than 100, then the result is true. Although the second part is not true, second part less than 0. 101, of course, is not less than 0, so it's false. But a true or false returns the true. And then the NOT operator reverses the truth of a Boolean expression. Is if I put a exclamation mark, then grade greater than 100. That means if the grade is not greater than 100, or it's less equal than 100. So one thing to note is the definition of the word and or. When you say in English, something, something, and something, sometimes you need to translate this into a or. It depends on how you raise the question. For example, if I say this course is available for students in CST department and CET department, what does this and mean? Can a student be both in CST department and CET department? Of course, no. When I say this course is available to students in CST and the CET department, what I mean is the course is available to students in CST department or a student in CET department. So when you see a question is giving you some conditions using an AND operator, or AND, the English word AND, you need to pay attention to it. If these are parallel conditions, very likely they are OR. They are actually an OR logical operator. If it's a CET department and CST department, then this likely is be an OR department, OR operator. But if they are not parallel, then it's likely an AND operator. For example, if it's that cold and raining, these two are not parallel. These two can happen independent of each other. So this is the AND. All right. So let's see the AND operator first. It takes two operands and must be Boolean expression. The result is true if and only if both operands are true. And here we have this logic formation. Anytime there is a false, the result is false. Only when both are true, it is true. And similarly, we have the logical OR operator. Two pipe chart takes two operands and must both be Boolean expression. The result combined expression is false if and only if both are false, or if and whenever there's one true, then it is true. Only when both are false, it's a false. So let's take a quick look at logical AND. So here you are entering an annual salary, and you're entering the number of years at your job. And here we have salary greater than 30,000 and years on job greater than or equal to 2. That's an AND. Only when both are true, this will be true. Let's say if I run and my annual salary, let me put 100,000, I wish. Okay, and the number of years, 3 years, and you qualify for a loan. You see that? You qualify for a loan, which means we get inside here. Now, what if I enter 29,000, but my year on job is 5 years? It says you do not qualify for a loan because my salary is less than 30,000. This one is a false. So the whole expression becomes false. Similarly, logical OR. Here we use a OR operator. Anytime this is met, then we will get a qualification. Let's say I run with the same parameter I entered, 29,000, and number of jobs, let's say I put 4, which means year on job is true. Greater than or equal to 2 is true. But salary greater than or equal to 30,000 is false. And we get this qualification. Okay. And then, other than this AND and OR, there's this NOT operator. The NOT operator performs a logical NOT operation. If an expression is true, it becomes false. If it was false, then a NOT expression will be true. So we have this if not temperature greater than 100, we have this below the maximum temperature. Now, logical AND and logical OR operators perform short-circuiting evaluation of expression. So in this case, if salary greater than 30,000, here, for this AND operator, it's easier to explain with AND. If salary greater than 30,000, now if my salary is less than 30,000, it's 29,000, then we already know this expression is false, right? As soon as there is one false, there's no need to evaluate the second one, because no matter what the second one is, we already get a false, and the result of AND will be false. Similarly, for AND OR operator, if salary is greater than or equal to 30,000, if it's 31,000, this expression itself is true. That no matter what the next expression is, whether it's true or false, the whole result will be true, right? As long as there's one true, and the result of our OR will be true. And for AND, as long as there's one false, the whole result will be false. So that's when Java introduced this short circuiting, where, excuse me, where you, as long as the first is evaluated, you do not need to, and you can determine the result. You do not to evaluate the rest. This helps in reducing the time to avoid some unnecessary calculation. Right now here, of course, year on job is a quick evaluation. But let's think if there's an if statement where you try to if exists, let's say the folder exists, and open file successfully. So these are two steps of your operation. You need to confirm the folder exists first. Then you can open file successfully, right? You can open file and read it. If folder does not exist, you do not even need to open file. So this is when short circuiting comes handy, because if there's nothing called short circuiting and both need to be calculated, then no matter what the result of folder, you will try to open file. But if the file doesn't exist, this is doomed to fail and will give you error message. But with short circuiting, we can check to make sure the folder exists first. Then we do open file successfully. So here we said logical and OR performs short circuit evaluation, and will evaluate false as soon as there's one false. And the logical OR will evaluate true as soon as it sees the one is true. And in addition, you can have a long combination of more operators, the and. You need to open file first, then you need to read the file first successfully, right? And then you will also need to close file. Let's say write to new file. You are allowed to write as many operators as you want and form a logical operation expression. And all these operands, each is a Boolean result, will be evaluated only when necessary, only when the previous one gets you the desired result. But then it comes the question, if I have ampersand, if I have both or and not in the same logical expression, what's the precedence of execution? Remember, the not operator has the highest order of precedence, then the higher order of precedence, than the and or operators. And operators have a lower precedence than relational operator like less and greater to less than and greater than. If you have any doubt, use parentheses to force the precedence to be changed. So here is an enhanced version of order of precedence for operators. And you can see actually ampersand and actually have a higher logical order of precedence than or. But although there exists this order precedence, I strongly encourage you to use parentheses, because logical operation can be tricky and can be complex. Without parentheses, it's very easy to lose track. And it's difficult to write and it's difficult to modify. Just like when we talk about if statement, I encourage you to use curly braces no matter how many statements you have in the block. Always use curly brace for readability and the maintainability. It's the same thing here. Use parentheses to make it more readable and more maintainable.